This is going to be a very short video demonstration on how we actually go about tuning our resonant power system and tuning our various motors. Right here you see the same motor we've used in our other videos, and if I come in here closely, you can see I've taken the terminals, and actually what we've done, we've just connected them together with two diodes, which are facing in the same direction. It doesn't matter which direction. If we reverse the direction, then the motor rotates in the opposite direction. But we have our transformer output, one of them, which is connected here to the junction between the two diodes at the terminals. And the other connection is connected to the casing of the motor, which is seen in our other videos. And over here, where our circuit board is, we have a voltmeter here, which is actually going to display the voltage that we put on our two capacitors here, which are powering the transistors. And of course the voltage is going to vary based upon how much power we turn up our variable transformer. Over here is our watt meter, and of course we have it set to amps right now because this is how we actually tune our system. So the variable transformer is connected in here, and of course it's outputting to the circuit board. And this here is a little variable pot which varies the resistance going into the circuit board. And as we previously stated, our circuit board frequency is determined by the value of the onboard capacitor and the value of the resistance that we put that changes the frequency of the chip itself. So the way we go about finding what the resonant frequency of any particular motor is, we look at the amount of amperage which is being drawn, which will vary depending upon how close to the resonant frequency we get to the actual operating system. And when amperage is at its maximum based upon any power output, we have determined what the resonant frequency is of that particular motor, and then we can measure that actually across the transformer coils to get the exact frequency number itself. Of course, here we're showing right now there's no voltage on the capacitors, but when we power it up, the capacitor voltage will increase up to a certain level, and then we'll show how whenever we tune it in and out of phase, how the capacitor voltage will either drop as we get close to the resonant frequency because we're drawing more current, or it will increase because we're getting away from the resonant frequency. The motor RPM itself, which of course we'll show in the video, will either increase or decrease depending upon any fixed power output going into the resonant frequency. So what we're going to do here, we're going to fix this to our little camera holder, and we're going to start the operation. I'm going to take my hand and I'm going to open up the power to the transformer. Right now the motor is spinning because we have it fixed to its resonant frequency. We'll turn it up a little bit. So presently we're showing about 383 milliamps. Of course the variable transformer itself takes over 50, and we're showing the capacitor voltage at about 134 volts while the motor is spinning. Now when we trim our pot, we're going to get out of resonance. As we get out of resonance, the actual amperage draw decreases and the motor RPM decreases and the capacitor voltage increases. as we start tuning closer to the resonant frequency of the motor, the amperage draw increases and the voltage on the capacitors decreases because we're loading them up more. See, we're getting away from resonance. As we get right at peak resonance, motor RPM peaks, amperage draws increases. And we're going to put a little bit more power into the system. So we can look at our capacitors voltage. If the capacitor voltage increases and the amperage decreases, we're getting away from resonance, even though the motor is still running. But then whenever we tune it the other way, we can find peak resonance right here. It's showing about 475 milliamps, and the capacitor voltage has dropped down to 154 volts. So we'll take it up a little bit more. $514 milliamps, 510, it kind of varies. We're getting away from resonance. The capacitor voltage increases, the amperage draw decreases. And you can also tell by the motor pitch. It's very sensitive. Turn it up a little bit more. We're getting away from resonance. If we get way out of tune, the amperage draw really decreases. And then we're in resonance. So this is how we tune our system. And then once we find the precise resonant frequency, we measure the resistance in these two little output terminals here with a resistance meter, and then we place our fixed resistor into our slot, found right here behind here, and that's how we determine what our resonant frequency is and how we can tune our motors to resonance. Thank you for watching this short demonstration.